All right. Welcome back, everybody. Thanks for all the feedback about yesterday. Please keep it coming in. We've received a lot of interesting feedback about co-presentations with Microsoft and external speakers. Some people are surprised that security researchers and Microsoft employees would be together on stage. That's really what it's all about, bringing people together here at BlueHat. There was a lot of curiosity about the keynote yesterday. Some people within MSRC are like, oh, so that's how the team started, and that's how some of these things came together. And it was cool to see everybody learning about that. And then, of course, people seem to really love Clippy. Clippy was running around yesterday afternoon, and I hear that Clippy may make a reappearance later today. One of the things that we announced at BlueHat last year was that we expanded our AI bug bounty. And we've learned a lot through that. So when you have a bug bounty, you want to be really intentional about what's in scope, what your goals are, all that kind of thing. And AI is really a new space. And so we've continued to evolve the bug bar and the bug bounty program as part of that. A lot of that is based on feedback that we've received from the external security researchers, many of which are presenting later today in that AI and ML track. And a lot of the attacks that we see are some of the typical security attacks. Some of these things are AI specific, though. I wanted to highlight one of the interesting bugs that came in. So somebody was interacting with an ML system, and they were trying to get access to the file system. And so they started chatting with the ML system and saying this was the LLM, saying, OK, let's go interact with the file system and create a file with these contents and name the file this. And so the LLM said, OK, I did that. So then the next thing they said is, OK, give me a directory listing. So the directory listing came back, and it had that file that the security researcher just tried to create. And it had some other files along with it, including some files with very similar names with tildes and stuff like that. So it looked like kind of temp files, backup files. And then the researcher said, OK, now read the contents of that file back to me. And it gave the contents back, same thing that the researcher put in. And so that bug submission comes in, and we go and look at it. And it turns out that they did not touch the file system. And the LLM is so sophisticated that it was a hallucination. And then we have a bug bounty program, so it gets a little interesting where we have to say, hey, it's not really what you saw. But luckily for us, the researcher knew some things were kind of suspicious when they submitted it, and they said, hey, I'm not really sure if this is real or not. But there are bugs like that a few years ago you wouldn't even imagine that you would have these repro steps that were kind of strange in hindsight. And while there are AI-specific attacks, a lot of the things remain, the core security fundamentals remain true to securing AI systems. So going and doing threat modeling, going and building defense in depth, these are all really important. And so with that, the engineering system is really core to everything that comes out of it. Everything is built on the engineering system. We know that. Attackers know that as well. People are going after engineering systems to impact the supply chain. And so our keynote speaker for today is Amanda Silver, and she's going to talk about how at Microsoft we secure the engineering system. I've had the pleasure to work with her as part of the SFI initiative. She's a CVP working on developer tools, platforms, and engineering systems. So please welcome Amanda Silver.
Make sure this is on. All right, y'all can hear me? Hi. Glad to be here at BlueHat. Thank you so much for the introduction. I'm really thrilled to be here to talk about this topic. I've I've talked about a lot of things in the developer space before, developer tooling, developer experience. Never actually talked about this topic, so I'm excited to talk about it today. So, as Tom said, it's really no secret as to why we're all here today. It's not a question as to if there's going to be another attack, but actually, when it's going to hit, where it's going to hit, how severe it's going to be. And that really all depends on how quickly we can detect and remediate it and address it. And so more and more we're seeing really software developers themselves, their workstations, their engineering systems actually be the target for threat actors, from SolarWinds to CodeCov to Log4j to XE. Developer watering holes is kind of how I think about it. And the infrastructure that they work on is really increasingly becoming the target that then becomes the critical dimension that facilitates the lateral movement. So earlier this month, CSO Online cited a new report from Sonatype that really sounds the alarm about the rate at which malware is infiltrating open source software. The company has tracked over 500,000 new malicious packages since November 2023 across Java, JavaScript, Python, .NET packages, all of those package registries. And the number of malicious packages on those registries, according to their report, has grown by 156% year over year. The previous year it was actually even higher. And that obviously poses a very significant risk for anyone who uses open source. And it really is an imperative for everyone to kind of manage their dependencies on open source really effectively. So let me just introduce myself real quick from my perspective. I basically have two jobs at Microsoft. The first is that I run the product teams that build all of our developer tools, Visual Studio Code, TypeScript, .NET, our contributions to Python, C++, the Rust compilers, all of that kind of stuff, our Azure DevOps solutions. We partner very closely with the GitHub team to build, advanced security for GitHub and Azure DevOps to build GitHub Copilot. And we also build in my team the PaaS layers of Azure, so basically the application platform. That's half of my job. The other half of my job is that I'm also the GM for our first-party engineering systems. And so in a way, you could think about this as we take the retail products that we ship to our external customers, and we manage them, we administer them, we host them, we extend them, and we incubate new technologies for our first-party Microsoft employees, for our Microsoft digital estate, and over 60,000 employees in the engineering profession at Microsoft. And our engineering systems are really the foundation on top of which all of our products are built. And because of that, they are a prime target for threat actors attempting to infiltrate our systems and our customers' environments. Now, you may have gotten word, and I know many of you are Microsoft employees, so I'm sure many of you have heard this before, but for those of you who are not Microsoft employees, I would assume that you've probably heard yesterday in yesterday's conference that about this new initiative that we're calling SFI, or the Secure Future Initiative at Microsoft. How many of you guys have heard of this? Everybody? Maybe not everybody. Let me just explain it a little bit. Obviously, as one of the defenders of kind of the most targeted estates in the world, Microsoft really, we obviously see firsthand the increasingly hostile security landscape, and obviously we recognize the imperative to address it as much as we possibly can. SFI launched in November 2023, and our CEO, Satya Nadella, made security the top priority for everyone at the company. I'm not just talking about engineers. I'm not just talking about the executive staff. I'm talking about our lawyers. I'm talking about the people in HR. I'm talking about literally everyone at the company now has security as one of their core commitments. And so, in some senses, everybody's like, okay, what can I do for security? Well, you can at least use multi-factor authentication. So this is really an education for everyone across the entire company in terms of how they can contribute and do their part to support security. But as I've been saying to my team for several months now, what this also means and this is true for our overall general business as well, is that there is no new feature, no new SKU, no new product that is more important than ensuring that the infrastructure that our customers take a dependency on for their mission-critical solutions is absolutely rock solid. And so that's the message that Microsoft is getting from Satya all the way down, right? And I think that, especially in this landscape, that is really the only kind of posture that we can take. So this company-wide initiative was really designed to advance how we design, build, test, operate our products and services so that we can ensure that we're delivering the solutions that meet the highest possible quality of standard for security. And we have the equivalent of 34,000 engineers working on it, making it, as far as we know, the single largest cybersecurity engineering project in the history of digital technology. And so we're empowering basically all of Microsoft to implement the changes that are necessary to deliver security first. And we're leveraging all of the insights that we've gotten, the best practices, so that we can deliver the world's most secure cloud. That's really what we want to be focusing on. So all of our work in Microsoft is now guided by these three principles. Secure by design. Security comes first when designing any new product or service. This means that, for example, I'm engaging with my design team, people who we think of whose primary job is to design the user interface for our products, to actually help them think about how they can create better designed user interfaces, but also obviously software engineers in terms of how they design the architectures for their solutions. Secure by default, that the security protections in our products are enabled and enforced by default. And that requires no extra effort on behalf of the customer. And it's not optional. At least internally, it is not optional, and we can make it optional for our customers. But if we do make it optional for our customers, we actually want to, warn them, help them understand the risk that they might be taking on. And secure operations. We have to make sure that our security controls and our monitoring are going to continuously improve so that we can meet our current and future threats. Now, every part of Microsoft is being brought together through this initiative to advance the cybersecurity protection across our company and our products. Now, the basics of the SFI framework are elevating security and SFI across the entire company, security above all else. You guys have seen that many, many times. And we've also identified 6 critical security pillars, and we organized the teams to be able to implement these. Protect identities and secrets, protect tenants and isolate production systems, protect networks, protect engineering systems, which I'll talk about in a lot more depth in a second, monitor and detect threats, and accelerate response and remediation. Now, in some senses, this is almost the first chapter of SFI, and as we are kind of uncovering the layers of what we need to do, we're realizing that there's more and more ways that we need to kind of look at our entire estate to figure out everything that we need to do to remediate it. But another kind of core principle of the way that we're approaching this is to continuously improve our standards and embedding them into the way that our engineers implement the products through paved paths. And this can happen at the architectural layer in terms of the way that they build, say a new Azure service or a new service for M365. But it also obviously happens in the way that they integrate into the engineering systems to go from their idea to code into production. And then we have to also make sure that we're ingraining all of this secure posture into the design, the principles, the secure by design, secure by default, and the operations in everything that we do. And that also means that, for example, we have to make sure that we're actually implementing, telemetry and monitoring for basically everything that we implement so that we can actually see what's happening. Now, when I mentioned that this is an initiative across all of Microsoft, I really mean all of Microsoft. That's over 18,000 organizations in terms of the, sub-organizations that we have inside of Microsoft from an engineering systems perspective. 167,000 repos, over 100,000 devs, engineers, designers, product managers. That was kind of the count before the Activision acquisition, so it's even more at this point. And just like, many of your organizations outside of Microsoft, we have a lot of legacy code that still needs to be maintained. 20-year-old code or more, 30-year-old code in some cases. And as a result of that, we have a breadth of a lot of different types of tools in our engineering systems, and also a growing number of programming languages and ecosystems that we need to support. So it is a lot of complexity. And the way that we can manage this, the only way that we can manage this is through the practice of what I call platform engineering, what the industry is coming to call platform engineering. So platform engineering, I think about it as DevOps plus. It's kind of like the combination of DevOps plus, kind of cloud native together. But it's basically built up. It's a practice just like DevOps was way back in the day, before it actually became products. That was built up from DevOps principles that seeks to improve every development team's security, quality, compliance, costs, and time to business value and developer experience through improving the developer experience and enabling self-service systems that enable secure, governed solutions and infrastructure by default, right? So the idea here is, for many people, when they want to create a new product, they actually have to go create a DevOps pipeline, they have to talk to the engineering system, and then they have to go talk to the ops team, then they have to talk to the security team, and they have to talk to basically every team across their company to actually get the infrastructure that they need. Obviously, when you have those kinds of human interfaces that are being required, there's going to be variation in those human discussions, and it's just going to kind of represent a lot of friction for the engineering teams. And so really what we're trying to do here is to make sure that we have these paved paths by default so that developers can be self-service. They can basically, they can be as agile as they can possibly be, but also from an engineering systems perspective and from a security monitoring perspective, we can actually understand what they're creating in the context of our environment and ensure that they're adhering to our best practices. In a sense, though, this is also a mindset shift. It actually requires that we think about our engineering systems through the lens of a product mindset. And let me talk about that for a second. But the solution that we have here is the set of tools and the systems that we use to support it. So, as the GM of the internal team that builds these solutions, this is really where platform engineering helps us. So we've invested in making sure that we have the mindset shift and we treat our engineering systems with that product mindset. So our customers are the individual developers on the team who use these products every day as end users, right? But we also have stakeholders, really important stakeholders, our operations team, our security team, the boardroom who cares about the agility of our engineering teams. So we have to kind of constantly make sure that we're satisfying all of these customers. But we've built basically this central team so that we can codify all of the best practices into these automated processes that reduce the developer toil. And the developer toil can come either through setting up infrastructure, or it can come through security response and remediation, right? And so if we can actually make sure that we're building a better foundation for engineering systems by default, it actually reduces developer toil. That's the key to what we're trying to do here. So we could not handle the scale of driving standardization and consistency across Microsoft's estate without thinking about this practice of platform engineering. And so in a sense, you could think about platform engineering as having three key motions. Now, I could talk about this all day. I'm obviously pretty passionate about this. But I just want to give you a little bit of context on these three motions as they come up in terms of how we think about how Microsoft has to protect our engineering systems. Start right. really focuses on equipping the developers with these self-service tools. And that allows them to kickstart their projects really quickly and adhering to the company's best practices that are defined through templates that are then automated and policies. And those start right templates include workflows and config as code that actually leads to the deployment pipelines that enable successful, efficient, and secure operations. Now, stay right motions like policy enforcement, security monitoring, observability, through all of that, organizations can govern their application estate to get better cost control and to reduce risk while delivering a great developer experience. And get right motions, which a lot of people call these get green or get clean. I don't love the term get green because there's always red, and red isn't bad. You just need to respond to it. But those are really the campaigns that we drive to eliminate the technical debt. And the technical debt can kind of happen in two ways. It can either happen because the code drifted since they first kind of came up with the project. It can happen because our standards evolved. It could happen because there's a new threat that we now have to respond to. And so there's many different ways that we kind of need to drive these get right campaigns. So now let's return to the Secure Future Initiative just to show you kind of the double click on what it looks like within the engineering system pillar. The goal of the engineering systems pillar is to protect our software assets and to continuously improve our code security through the governance of the software supply chain and our engineering systems infrastructure. So this is an enormous goal, and acknowledging we are not perfect here. But we're approaching this through the lens of continuously learning and improving our products and our infrastructure so that we can protect both our solutions and our customers' solutions. So with all that said, let's take a quick look at the 5 objectives that make up the engineering systems pillar. In a sense, these keywords that you see highlighted here, when we first realized that we were going to be bringing the Secure Future Initiative company-wide, I got a call Friday night, very, very late, and got the word, hey, we're going to be doing this, and I'm going to need your help, given that you run the engineering systems team. And so, it's one of those late night calls that you spend time kind of thinking about, even when you're not intentionally thinking about it. And these are really the 5 key themes that came to mind, those words. So let's just talk through it. Number 1, we have to build and maintain the inventory for our software assets that we use to deploy and operate our Microsoft production environments. Inventory is just so critical to facilitate rapid response and remediation, and to also continue to maintain compliance with our ever more secure standards. So we cannot do something like a get right campaign without actually having an inventory. Today, this is actually a system that is internal only. We don't have an equivalent retail solution of what we use internally inside of Microsoft to what we've built for our inventory system. But it is an essential component in terms of how to facilitate this. So as we saw from the recent Salt Stack exploit, publicly known vulnerabilities can really be exploited very quickly. And as a part of our Get Right campaign and our platform engineering motion, over the past several years, we've driven major campaigns to prune our unintended repos and to understand which remaining repos are production related. And this has really immeasurably impacted and helped improve our focus for our efforts. It helps us reduce the noise from the findings so that we can focus on what actually represents the highest risk. And it effectively has improved our MTTR, our mean time to remediation or response, when the security issues arise. Now, since some of the earliest open source incidents, we've really continued to improve our open source incident response process. And so now we can actually block known bad packages on our deny lists and enable central notification to all of the affected teams within just a few hours, which is much improved. Now, the second big point is access. In the before times, developers built on their own build servers, and they copied binaries over from one build server into the production environment. And we don't live in that world anymore, or we definitely don't want to live in that world anymore. So we're really trying to apply zero trust and least privilege policies to secure access to source code and engineering systems infrastructure. Now, this is a defense in depth approach that really ensures that only authorized personnel have access to those critical resources and to pathways to production. This is a really critical step. Now, in the interest of transparency with you all, one of the things that is an important tension here is supporting the culture of inner source, and security, right? Because yes, we want to protect all of our assets, but we also want to support collaboration and code reuse inside the company. And so our goal is to be able to allow developers to search for less sensitive source code, to facilitate code reuse as much as possible. And our current approach is to really make sure that we're standardizing the access groups based on our organizational hierarchy, and also support easy experiences to approve access if somebody wants to contribute to a code base in a sister team. And also, provide search capabilities for folks so they can kind of, learn, but not necessarily have write contributions into all of that source code as well. So the third big dimension is code security. Now, every single line of code, this is our aspiration, that deploys to Microsoft production environments really has to be fortified with state-of-the-art security checks. And we have to make sure that all the code that we implement is secure, and that we're continuously eliminating categories of attack surface area so that we can continually improve our products. So 2 examples of how we do this is to remove secrets from code as an example, using GitHub Advanced Security to make sure that we're improving the threat modeling across the company and that practice. Other examples of how we eliminate major categories is making sure that we're migrating more of our code bases to memory-safe programming languages. And so that's kind of one of the kind of important dimensions of this. Now, the fourth big dimension is isolation. By standardizing and securing our build and release systems through these governed pipelines and isolating our dev test environments from our production environments, that will allow us to have consistent and secure continuous integration, continuous deployment solutions across the board. And that will reduce the risk of lateral movement into the production environments. Now, one of the tools in our arsenal that we have that facilitates this, but it is kind of a challenging thing to kind of use at the scale of Microsoft is, but it really facilitates the separation between dev, test, and prod, is Azure deployment environments. And that allows platform engineers to set policies and settings on various different types of environments and control which Azure resources people can create, developers can create, and really track those environments across feature branches and kind of all the different kind of ways that they might deploy these things. One of the things that today developers really struggle with is setting up all of the cloud-managed resources that their applications depend on. And it's really error-prone and prone to configuration fails or other things like that. And we don't really want every single developer to have to become an expert in kind of Frankly, developers don't love writing YAML. They don't love it. They don't want to write it. So this actually saves them a lot of time. But it also, allows us to kind of have more consistency across all of this. And through this, they can then apply Azure governance and policy based on the type of environment, sandbox, testing, staging, or production. Now, another tool in our toolbox is managed DevOps pools. Now, this is something that we actually developed internally in Microsoft first. We've been using it for the last couple of years and have been rolling it out as part of our standardized build pipelines. But basically, this is a way to make sure that we're driving centralized, governed build infrastructure for all of the builds across Microsoft in this case. But this is actually a feature that we're going to be bringing to our third-party customers at Microsoft Ignite in a couple of weeks. But this really helps to ensure that we're actually centrally managing and governing those build pipelines so that the build infrastructure cannot be compromised, or at least that we have a more qualified central team that's basically monitoring all of those pipelines. So the fifth objective, which is obviously super critical, is supply chain security. So we're building a more secure software supply chain to protect every component in our production environments and products, which includes aggressively burning down critical open source vulnerabilities through package upgrades and standardizing on Microsoft vetted package feeds. And we're super laser focused on code integrity as well to ensure that only services in our production clouds are those that have been built using our production tool chains. Now, as we look at this space in terms of the maturity framework for safe OSS consumption, using the secure supply chain consumption framework, that allows us to have inventory, audit, and to track our OSS usage in the event of a new zero-day vulnerability getting declared. So Microsoft developed the S2C2F, that just doesn't quite roll off the tongue the way that I would like it to, since 2019. And we've continued to lead and maintain the framework as a part of the OpenSSF. So the 8 practices in the S2C2F, thank you. They work together as part of a holistic strategy so that you can secure the team and organizational supply chain. And so it starts with ingest, to make sure that your teams are consuming open source through an artifact repository like our Azure Artifacts or JFrog or something like that. And so that way you can actually continue to build your solutions even if the upstream goes down. Now, you also need to enforce, and that ensuring that only OSS can be consumed through the artifact repository so that you can really gain control over how dependencies are brought into your supply chain. And that this is part of establishing the paved path with those guardrails. So then these SCA tools like dependency scanning can then collect a more accurate inventory and scan for legal risks, vulnerabilities, malware, et cetera. Now, by improving our inventory, SCA and other tools like Dependabot, which is part of GitHub Advanced Security, that really helps developers to update their known vulnerabilities very quickly. And that allows security teams to also audit to make sure that the known vulnerabilities are being addressed as part of a Get to Green campaign. Now, we've published all of the high-level solution-agnostic set of practices with a detailed list of requirements for each practice and real-world supply chain threats that are specific to OSS and how our framework mitigates them. So for those of you, outside of the Microsoft team who are interested in this, you could check out that link at the bottom for some recommendations. Now, internally, we continue to invest in what we call central feed services. And this is an extension of Azure Artifacts that's designed to protect against vulnerabilities that are stemming from the consumption of public packages. So CFS really ensures that packages are pulled from secure internal registries, and they provide ingestion gates for OSS, looking at malware, looking at provenance, and it provides ongoing continuous scanning with the latest tooling signatures, SAS, DAST, and it's transparent to the developer experience. So really, the developer experience doesn't change at all. It looks like they're just consuming a package directly from NuGet or PyPy or wherever. But essentially, we make sure that our build systems are pointing to this central feed service. Now, it's not just about us making Microsoft more secure. I also want to call out that, especially given that we have retail products, we have package managers that Microsoft actually delivers, we also need to think about our responsibility in terms of securing the entire ecosystem. That protects Microsoft, and it protects all of our external customers. And so we continue to make really significant investments in the broader ecosystem to secure the consumption of packages and to reduce the blast radius for the ecosystem. So, for the NuGet team, just as an example, for the last couple of years, even before the Secure Future Initiative, their big focus, their number one priority actually has been improving the security of the ecosystem. So, here are just a few of the examples of the work that we've done in NuGet. .NET Restore audit improvements really helps you to check all of your dependencies, including direct and indirect dependencies. Transitive dependencies helps you know that what your hidden dependencies are, both at a project and a solution level. OIDC Trusted Publishers enhances security with robust authentication, and it enables convenient access across multiple services through single sign-on. And that makes our systems easier to use and more secure. And obviously, in some senses, the Cyber-EO Act and kind of the requirement of SBOMs has also had a pretty dramatic impact in terms of the requirements across the entire ecosystem of engineering and kind of the developer world. And so one of the things that we've been doing is to ensure that NuGet can facilitate building SBOMs properly. And then .NET NuGet Y displays the full dependency graph for a specific package within a project or a solution. And so we're going to continue to partner with the OpenSSF foundation to make sure that we're continuing to improve our open source insights. And in some ways, from my perspective, NuGet is one of the package managers that Microsoft really kind of fully controls. And so I think that we have an opportunity with NuGet to actually show, some thought leadership in terms of how we can improve and secure the ecosystem for the entire, .NET community. And hopefully that can then kind of spur additional package managers to also adopt similar practices. Now, this all sounds good, yeah? So far? Yes? Okay. But it's also not enough, and I just want to call that out. Detecting the issues, making sure that we have all of the security vulnerabilities identified, it doesn't actually solve the problem if the developer never takes action, right? And so we have to think about the actual ergonomics for the developers. We have to make sure that they are not barraged with a wall of issues that is going to represent tech debt that they then have to take literally years to burn down manually. And so we really also want to make sure that we are, not just finding the issues, but fixing the issues. Yesterday was GitHub Universe. We were talking about the found means fixed, right? That's kind of our adage, is we want to make sure that once we find it, that our tools and our systems actually automatically helps the developers. It just makes it so easy for the developer to fix the issue once it's found. And so, inside of Microsoft, we use Dependabot, which is, again, part of GitHub Advanced Security, to facilitate developers to, once we find a vulnerability, for them to upgrade their package so that they can build more secure software. I just want to talk about culture and the security mindset really quickly. You guys have all heard about the XZ attack, so we're just kind of dig into that a little bit earlier. But at the center of this was Andreas Freund, who is a Microsoft developer who kind of detected it. I just want to acknowledge that we were so lucky that we had Andreas from the Postgres team in Azure, who was doing benchmarking on the test branch of Debian, and he was spending time digging into the profiler, and he was seeing some issues in the remote connections. And so the analysis, obviously in the security community, you all are building amazing YouTube videos that go, very, very deep into all of this work, amazing work. But essentially what the library does is it alters the symbol table and it hijacks the calls to RSA to decrypt from SSHD. And as part of the certificate CA signing key, it actually contains the hacker's commands, but only if the hacker has signed them with their key. So it's a pretty sophisticated attack. But I just also want to call out that this is really a social engineering attack. So if we go back to the XZ mailing list in 2022, the attack actually started much, much earlier. This is really a long game type of attack. So if you've worked in open source communities before, you know that the conversations that I'm going to show you here are really not unique. And it's definitely easy to assume that, that these are someone who is really trying to contribute back. And it's unfortunate that we're just realizing just how careful we need to be in the open source space. And we can't really trust what people are saying, that they always have, kind of positive intentions from a contribution perspective. So here's the maintainer of the XZ project, Lasse Collin, and he's noting there that he's been struggling with mental health issues because of the pressures of basically maintaining this pretty significant component. Now, you've heard of a Nebraska dependency. It's a reference to this XKCD sketch. And so, in a sense, this is a great example of an XZ dependency, a Nebraska dependency. So going back to the newsletter and following what happened in 2022, essentially he's saying, why don't you pass off the ownership, the maintainership to somebody else then? And finally, we see Lasse, the maintainer of the project, come back and say, this other person, Jiatan, has been helping me quite a bit in the background, and maybe he can help me a little bit more in the future. And he created a GitHub account in 2021, and this looks pretty solid as an open source contributor goes. And he has lots of GitHub commits, he has an avatar, he's very active, But here's where they contribute the backdoors. The pull request is accurate. Yep, there's stuff in those files. And they alter and they build and more. He's really, really contributing in a really meaningful way. And that actually is protecting anybody from detecting that he's trying to do what he's trying to do. So here's the evil pull request. This is essentially a very large false value. So here you can see that they also contributed to this Google fuzzing project to replace themselves as the maintainer in case any fuzzing issues came up. And if you actually look at the GitHub repo, you're not going to find everything. The actual attack files are inside the tarball only. And so a lot of Linux distros will pull a tarball in and build it as opposed to cloning the Git repo and so on. So you wouldn't really see it. And also interesting in this case, the hackers modified the .gitignore file, and they've actually said here, don't check this build to host .m4 file because that's my backdoor, so let's just include that backdoor. So it's really interesting to see all of these breadcrumbs here. And in unraveling this, Andreas really personified what we call the security mindset. And I think that's a really key element of security culture. He was curious, he was vigilant, and he took his responsibility to take the findings to light. And so I just want to close where I began this morning. It's not a question of if there's another security attack coming. It's really a question of when it will hit, where it will hit, and how severe it will be. And I just want to kind of encourage everyone here to think about Andreas Freund. Let's just talk about him as an example. What was super interesting in that first weekend when, even before the New York Times article hit, he reached out to me. I think a mail got forwarded to me eventually, and I reached out to him just to say like, hey, how's it going? How can I help you? And I think one of the things that I learned from working with Andreas during this period is, as much as we have a security culture inside of Microsoft, and we have things like Report It Now, which basically every employee at Microsoft knows to use if they see something. I think about this as almost like you see a backpack by a trash can in the train station, right? You see that, it's abandoned, right? You see that, it looks somewhat suspicious. If you see somebody who's an authority figure walking by, you're probably going to let them know, hey, that's a thing you should go check out. And so essentially what Andreas Freund did was the equivalent of seeing that backpack and telling somebody about it. And he did use Report It Now. But Andreas was also an acqui-hire to Microsoft. He came in through an acquisition. He was not in the company very long. And he was a career open source maintainer, contributing to Linux kernel, Postgres, other things like that. And so he wasn't necessarily embedded in the overall Microsoft culture. But I think that that's something that we all really need to think about. If you think about your teams, who really understands what to do when they see something? And are they going to get the support that they need when they see something and they report it there? So, for Microsoft, we have Report It Now. That's what you should be using if you see something. But also, for anybody who works with other friends in teams, or works with teams that have come in through acquisition, or works with open source maintainers for components that we have a dependency on, think about how you can actually help them as well, so that we can all really have this security mindset to make sure that the digital world is more protected. So thank you very much. Have fun at BlueHat.
Thank you so much, Amanda.